Okay, now let's continue our study. We talk about section 1.2. One point two is about quadratic equations. So what is a quadratic equation? Quadratic equation means the following thing. So the definition. A quadratic equation is an equation equivalent to the form ax squared plus bx plus c equal to 0, where a, b, c are real numbers and a cannot be 0. So we must have this x squared term. Okay? And this ax squared plus bx plus c is called the standard form. The standard form. Okay, so when we say equivalent means sometimes the quadratic equation is not in the standard form. You can do some algebraic manipulation to make it equivalent to this standard form. Okay, and because here the highest degree is 2, so this is also called a second degree equation. A second degree. Linear equation, last time we discussed the linear equation, that's a first degree equation. This is second. Okay, so there are several methods to solve this equation. When we have an equation, we try to find the solution or solution set. So there are several ways to solve a quadratic equations. The first, we solve it by factoring. Solve the quadratic equation by factoring. Okay, so how do we solve it? For example, we have this equation. First one, x squared plus 6x equal to 0. When we have this, in this case, the c is equal to 0. When this happens, you see here, you have two terms, x squared and 6x. They both contain the common factor x. So we can factor out x. We factor out x, we get x times x plus 6. A product is 0. Either first factor is 0 or the second factor is 0. So this is equivalent. It is to say x equal to 0 or x plus 6 is equal to 0. Either first factor is 0 or second factor is 0. X equal to 0, that is the solution. X plus 6 equal to 0. You move 6 to the other side, you get a negative 6. So x is negative 6. So the solution set is 0 here and negative 6. Two solutions. Okay? So that's a factorization. This is a simple factorization because it two terms contain the common factor. Whenever c is equal to 0, you can always do this factorization by factoring x, and then you divide it into two parts. Separate it into two parts. Okay? It's a simple factorization. And sometimes or in general, c is not equal to 0, so you have 3 terms. If you have 3 terms, let's see, first you put it in the standard form. You're going to move x and 3 to the left side. And here we are going to review the useful and important factorization property. So we are doing the following thing. We factor the coefficient of x squared. 2 can be factored only either 1 or 2. It doesn't matter you write 1, 2 or 2, 1 in whatever order. It doesn't matter. So just write them. And second, you can factor -3. This time, whenever you read the coefficient, you have to read the number with the sign. You see here, A, B, C, they all have positive sign in front. So it means when you read this -3, it's actually plus -3. So C is -3. So here, let me write it. A is a 2, and B is -1, and C is -3. Okay? So important, it's very important. Here you have to consider -3. For -3, there are so many factorizations. You can write like 1 times -3, -3 times 1, something like this. Okay, so we are going to try. We have to try. For example, if you put -3, 1 here, assume you put a -3, 1, -3 and 1. The product is -3. And then you're going to do the cross multiplication. So 2 times 1 is 2. -3 times 1 is -3. So you have two numbers, two products. And when you get two products, you add them. -3 plus 2 is -1. You check if this is equal to v. If it is equal to v, for this case, we are lucky. So it is equal to v. When this happens, you're going to put x here, x here. Okay? So you read like 2x minus 3. X, here no sign means plus. X plus 1 equal to 0. This is the factorization. Okay? So after you factor it, a product is 0. Then either 2x minus 3 equal to 0 or x plus 1 is equal to 0. So 2x minus 3 is equal to 0. So 2x is 3, x is 3 halves. X plus 1 equal to 0, x is equal to -1. So the solution set is 3 halves and -1. In the solution set, order does not matter. You can write the -1, 3 halves. Either works. Okay, so this is a very, very important but sometimes tricky method. So you factor the you factor the coefficient of x squared. You also factor the c, but you have to factor them properly and place them smartly, so that when you do the cross multiplication, you have two numbers. You add two products, is exactly the midterm v. If this is correct, you put xx in the corresponding positions, and then you get the factorization. Okay, so this method is very, very important. You must practice with the recommended exercise. Okay, so that's a factorization. So for example, when you have factorization like this, you see this one, we are going to, the coefficient of x squared is 1, so it's 1 times 1. Here is c is also 1, but because we are looking for the sum, final sum is negative number, so we are going to factor 1 as -1 times -1. So -1 times -1 is still positive 1. 1 times 1 is 1. You see here, that's the tricky part. You don't know what's a proper one. You have to check the midterm. Midterm requires negative number. And then you check that product, cross product. 1 times -1 is -1. 1 times -1 is -1. -1 plus -1 is -2. It's exactly b. So you put x here, x here. So it's a x minus 1, x minus 1. Okay, that's a similar process. X minus 1, x minus 1, so you get either x is 1 from the first factor or x is 1 from the second factor. You have two same solutions. It's called a repeated solution. It's called a repeated solution. Or a root, it's the same name, the different name for the same thing. A root of multiplicity 2, or a double root. See, it's several names, but it just means when you have the same answer from two different branches. Okay. Okay, so here's another example about this repeated roots. For example, we're trying to solve this equation. This moment, you see 9. 9 can be 1 times 9, can be 3 times 3. Several choices. You have to try. I mean, before you do enough examples, you have no idea which one is the best one. You have to try. You possibly will put 9 times 1, or -9 times -1, or 3 times 3, or -3 times -3. Okay? And here, this one, the proper one will be 3, 3. Because finally we want 6. If you put 9 there, it's too big. I mean, that's explanation after I know the answer. Before that, you must try. Okay, 9 and 3 times 3. I want -6 in the final sum, so I have to write 1 as -1 times -1. 1 is a product and -1 times -1. So you check the cross product. 3 times -3. 3 times -1 is -3. 3 times -1 is -3. So you add them. It's exactly -6. It's b. Okay, so that's good. Then you put x here. So 3x minus 1, 3x minus 1. Okay, so 3x minus 1 is equal to 0, or 3x minus 1 is equal to 0. So 3x is 1, x is 1/3. Or here it's the same thing, x is 1/3. So you see that the solution set is 1/3, and you can say it is a repeated solution or double solution. It is a double solution, double root, double solution, same thing. Okay, let me see if you can read it. Okay, good. So sometimes you have two solutions, sometimes you have a repeated solution. And let's see another special case. Remember the first case, we say the first example, we assume this c is equal to 0, then you directly do the factorization. Possibly let's see, for example, b is equal to 0. There's no x term, just x squared and the constant for arbitrary p. And we know that x squared is at least 0. So here, if you want some solution, this p must be non-negative, greater than or equal to 0. If p is less than 0, then there's no solution. And for this one, we can take square root. We take square root, we will have two possibilities. One is positive square root, the other one is a negative square root. So x is a square root of p, or x is a negative square root of p. Okay, so there are two there are two solutions. There are two solutions. And we are going to use this to develop some computation. Okay? So first, let's get the concrete number, x squared equal to 5. X squared equal to 5, then x is a square root of 5, or x is a negative square root of 5. They are the solutions. They are the solution. Another one. If you have x minus 2 squared equal to 16, then we do the similar thing. It doesn't matter you have x then square or x minus 2 then square. Whenever you have square, you take square root. So you get either x minus 2 is a positive square root of 16. Square root of 16 is a 4. Or x minus 2, you consider this as a one variable. Or x minus 2 is a negative square root of 16. Negative 4. See? So either positive or negative. Square root, you always have two square root. Without additional condition, you always have two square root. Okay, then x minus 2 equal to 4, then x is 6. X minus 2 is negative 4, x is negative 2. So the solution set will be negative 2 and 6. That's how the solution set. Okay, so this last example gave us an idea. If we can write it as a complete square equal to a number, then the problem is solved easily by taking square root. So can we generalize this to the arbitrary quadratic equations? So that's a second method, completing square. Solve a quadratic equation by completing the square. By completing the square. Okay, I can read. What do I mean? First, before we go through this, we need a formula. You see here, x plus y squared is equal to x squared plus 2xy plus y squared. This is complete square. X plus y, the quantity squared, is x squared plus 2xy plus y squared. And this completing square method is this way. We have this sum. We want to write it as a quantity square. Okay, so let's try. Example. We have this quadratic equation, x squared plus 5x plus 4. How do we do that? First, I move this 4 to the right side. And I'm trying to apply this completing square method. I need x squared. I have it. 2xy. There's no 2. Multiplied by 2. When you multiply it by 2, you have to divide it by 2. And x. So it's the same thing. It's still 5x. But you see, you check here. X squared, 2xy. X squared, 2x. And then this is supposed to be your y. So this is y. And then you need a y squared. You don't have y squared. Add y squared. You add y squared on the left-hand side, you also add y squared on the right-hand side. Okay, see here? They are on two sides, they are balanced. The equation is still balanced. And now this left side is x squared plus 2xy plus y squared. So by the completing square formula, it is x plus 5 over 2 and quantity square. On right side, let's check. It's a negative 4 plus 5 over 2 squared is 5 squared over 2 squared. So 5 squared over 2 squared. So it's 25 over 4. 25 over 4 plus negative 4 is 9 over 4. You first write this negative 4 as negative 16 over 4, and then you will get 25 minus 16, you get 9 over 4. Okay, so that's a way to get this 9 over 4. Okay, what do we have? Let me copy it here. This is what we have so far by completing the square. You have this. Remember the last example we had? The last example, we take square root, we get plus square root and minus square root. Square root of 9 over 4. Remember 9 is 3 squared, 4 is 2 squared, so it's a 3 over 2. Square root of 9 over 4 is a 3 over 2. This is a positive square root. You also have a negative square root. You also have a negative square. You always have 2 square roots without additional information. Okay, good. Then from here, you see your x is 3/2 over 5/2, or x is negative 3/2 over minus 5/2 minus. Okay, this is negative 2 over 2. 2 over 2 is negative 1. Or negative 3 plus 5 is negative 8 over 2, negative 4. So the solution set is negative 1, negative 4. Okay, so this is a completing square method. Let's go over it again. How do we apply this completing square method? We first move this constant number to the right hand side. And second, we artificially create a coefficient 2, because in the formula you see there's a 2, so we need this 2. When you multiply it by 2, we're going to divide it by 2, so it's 5 over 2. Then you have x. Then you read this mixed term, 2xy, 2x 5 over 2, so y is 5 over 2. You have 5 over 2, you need 5 over 2 square. So you add 5 over 2 square on the left hand side. And right hand side is negative 4, you also add 5 over 2 squared on the right hand side. After you get this, the left hand side has 3 terms. They are exactly the form of the completing square. So you just write it like x plus 5 over 2. And right hand side is compute. That's pure number computation. You get 9 over 4. So x plus 5/2 squared is 9 over 4. You take square root, you compute, you get solutions. And by the way, here is a addition, then it's a plus. There is a counterpart. If x minus y, if I have x minus y, then this mixed term is a difference, has a minus sign also. And x squared, y squared always have positive sign. Here and here always positive sign. The middle term, its sign depends on the sign in the inside the square. Okay? Let's do another example. Let's do another example. So we have 2x squared minus 8x and minus 5. So first we move 5 to the other side. And second, you see here, x squared has no other coefficient. Here you have 2. We don't want this 2. How do we do it? We divide the equation by 2. All the terms are divided by 2. Okay, so we need x squared with coefficient of 1, or without a different coefficient. And And next, x squared minus 4x. Check here. So we need minus 2xy. 4 is 2 times 2. It's minus 2 times 2 times x. So from the formula, you see that the y is equal to 2. The first 2 is from the formula. Second 2 is a y. So y is 2, you need y squared, have 2 squared. Right? Right-hand side already has 5 halves. And you add 2 squared on the left-hand side, you also add 2 squared on the right-hand side. And then the left-hand side becomes x minus 2 squared, and right-hand side, 2 squared is 4. So it's 13 over 2. So it's equal to 13 over 2. Right? At this step, it is close to the same thing as the previous example. So you get x minus 2 square root of 13 over 2, or x minus 2 is negative square root of 13 over 2. Two solutions, all. And you move 2 to the right hand side, you get x is 2 plus square root of 13 over 2, or this one you move to the right side, x is 2 minus square root of 13 over 2. So the solution set. Is the solution set. Right? So this method, this completing square method, is a very straightforward method. It does not require some smart idea. It just, once you learn it, you just follow the steps and step by step to solve it. Okay? Factorization depends on some smart insight, and you have to observe which one is a good one, or a good one for the factorization. Okay? So this completing square method actually can give us a formula, like the quadratic formula. Solve a quadratic equation using the quadratic formula. So what is a quadratic formula? Technically, we just go through the last example again, but in the abstract way. So let's recall what we had. When we have this standard form of the quadratic equation, what did we do? Let's do it step by step. What did we do? We first move this constant number to the right hand side. Then you get 5 instead of a negative 5. Here, because it's a letter, when you move it to the right hand side, you put a negative sign. This is a positive sign. Move to the other side, it's negative sign. And second, we divide it by the coefficient of x squared. So here we divide everything by a. Okay, so the first step, movement. Second step, division. Third step, we put a 2 and divide 4 by 2. Okay, we multiply by 2 and divide by 2. This number 2 will be used in the formula, and this is your y. So you're going to add b over 2a squared. This is the left-hand side. The right-hand side, you also add this b over 2a squared. Okay, and then the left-hand side fits the formula, so you get x plus b over 2a in quantity squared is equal to this. What is this? It's a b squared over 4a squared minus ac c over a. So b squared 4 2a squared is 4a squared. 2 times a quantity squared is 4a squared. And in order to do this subtraction, I'm going to multiply top and bottom by 4a. So the right hand side is actually b squared minus 4ac over 4a squared. Over 4a squared. And now there is a discussion. If this quotient is a negative number, no solution. No solution. A square cannot be a negative. And remember that this denominator 4a squared is always positive. In order to get a negative number, you have to get a negative numerator. So this is equivalent to the situation b squared minus 4ac less than 0. No solution. You divide a negative number by positive number, you still get a negative number. You divide a positive number by positive number, it's a positive. Okay, so that's a discussion. When this b squared minus 4ac is less than 0, there's no solution. When b squared minus 4ac over 4a squared is equal to 0, the right hand side is 0. If it is equal to 0, then x plus b over 2a has to be 0. Only 0 squared is equal to 0, right? So x is equal to negative b over 2a. But remember, there are two terms, so you have two solutions. It is a double root. And a fraction is 0 if and only if numerator is 0. So when the numerator is less than 0, no solution. When the numerator is equal to 0, two same or two repeated solution. If the numerator is positive, third case. Numerator is positive, divided by 4a squared is also positive. Okay? So when the numerator is positive, then we get x plus b over 2a squared is equal to this. Let me copy it first, and then we continue it on this page. And then we take square root, we will get x plus b over 2a equal to positive square root of b squared minus 4ac over 4a squared, or x plus b over 2a is equal to negative square root of b squared minus 4ac over 4a squared. Okay, and you move this b over 2a to the right hand side, you move this 4a squared outside, you will get x is negative b over 2a. It is moved to the right side, so it becomes negative. Plus or minus, here's a plus, here's a minus. Remember, two choices, I write it in one. So 4a squared square root is 2a, square root of a b squared minus 4ac. Okay, the formula, we write it in one line. So two solutions, one it is greater than 0. Negative b plus or minus square root of b squared minus 4ac, the quantity divided by 2a. The quantity divided by 2a. This is so-called the quadratic formula. And this quadratic formula can only be applied if there's a b squared minus 4ac positive. Okay? And because you see here, this quantity, negative, no solution, equal to 0, a repeated solution, greater than 0, two different solutions, it is very important. It has a name. So b squared minus 4ac is called the discriminant of ax squared plus bx plus c equal to 0. The discriminant. The quadratic formula for ax squared plus bx plus c equal to 0 is this one. X is negative b plus or minus. This means you have a choice. The choice will give you two solutions. If this discriminant negative, no solution, so there's no quadratic form. When it is greater than or equal to 0, a repeated solution, a double solution, it still has two solutions. But if it's greater than 0, you have two different solutions. Okay, so the discriminant, this is on page 7. On page 97, you will read that discriminant. Very, very, very important. Okay. After we get the quadratic formula, then to solve a quadratic equation is just a routine computation. 3x squared minus 5x plus 1. So what is x? X is 2a, 6. Negative b, remember in the formula it's negative b. And b contains a sign. Negative b, b is a 5, negative 5, sorry. B is negative 5. So negative b is a positive 5. Plus or minus square root of b squared, 25, minus 4 times a times c. So it's a 5 plus or minus 4 times 3 is 12. 12 times 1 is 12. 25 minus 12, 13. Okay, this symbol means 5 plus square root of 13 over 6. 5 minus square root of 13 over 6. Two choices give you two solutions. Is the solution set. The solution set. You have to put plus here to get one solution. You put minus here, you get the second solution. Okay? And let's see another example about this application of quadratic equation. Quadratic equation, for example, you have 25 over 2 x squared minus 30x and plus 18. Okay, so we prefer to use integers instead of rational numbers because when you have rational number, you have to compute, it's complex. So here you have denominator 2. You are going to multiply the equation by 2. 25 over 2 times x squared times 2 is 25x squared. 30x times 2, 60. 18 times 2, 36. Now this is your new set of A, B, and C. So A is 25, B is negative 60, and C is 36. Okay, now let's follow the formula. Remember that x is 2a negative b plus or minus square root of b squared minus 4ac. A is 25, 2a is 50. Negative b, b is negative 60, negative b is 60. Plus minus square root of b squared, 3,600, minus 4, a 25, c 36. 4 times 25 is 100. 36 times 100 is 3,600. 3,600 minus 3,600 is 0. So 60 plus or minus 0 over 50. Plus 0, 60. Minus 0 is also 60. So x is 6 over 5. 60 over 5 is a 6 over 5. And it is a double root. It's a double root because you have plus case, also you have minus case. It's a double root. The double root comes from the fact that this discriminant is equal to 0. Okay? So this is a case when the discriminant is equal to 0. Now let's see the example when the discriminant is less than 0. Three x squared plus 2 equal to 4x. Remember, the quadratic formula can only be applied when you have the quadratic equation in the standard form. So here, first you have to move this 4x to the left hand side. And then you see that a is 3, b is -4, and c is 2. Okay. A, b, c must contain the sign if there's a negative sign. Okay, the solution will be negative 2a. Sorry, the ratio, the fraction, the denominator is 2a. Numerate negative b, 4, plus or minus square root of a b squared, 16, minus 4a c. Well, 16, 4 times 3, 12, times 2, 24. 16 times minus 24 is -8. We don't have a negative square root of negative number. Square root of negative number does not exist. So far. So the equation has no solution. The equation has no solution. Okay, and this is exactly the case when the discriminant is negative. Positive, two different solutions. 0, double solution. Less than 0, no solution. Okay, another example. So we're trying to understand the strategy based on examples. So sometimes your formula or your equation is not that close to the quadratic equation. It looks like 9 plus 3x, 3 over x minus 2 over x squared. X is not 0, its denominator is not 0. So in order to write the standard form of this quadratic equation, we are going to multiply it by x squared. The 9 times x squared, 9x squared. 3 over x times x squared is plus 3x. Minus 2 over x squared times x squared is 2. 0 times x squared, 0. See, now we have a standard form of a quadratic equation. A is 9, b 3, and c is -2. So x is 2a, negative b plus or minus of b squared minus 4 times a times c. Don't forget negative sign. C is equal to -2, not positive 2. Okay, so 9 times 9 times 2 is 8. 8 times 9 is 72. Negative is positive. Right? Just compute it. 9 plus 72, 81. 2 times 4 is 8. 8 times 9 is 72. Plus minus is plus, so 81. Square root of 81 is 9. Okay, so x is -3 plus 9 over 18. -3 plus 9 is 6. 6 over 18, 1 over 3. Or x is -3 minus 9 over 18. Minus this -12 over 18 is a negative what? It's a 6 times 2, 6 times 3 is negative 3 halves. So the solution set is 1/3 negative 3 halves. Okay. Okay, so that's everything we need to know about the abstract quadratic equation. Now let's see one application. We use a quadratic equation as a model. Okay, so what is the problem? The problem is like this. Let me try to read it. Now you have a square of certain metal. Okay, this is, I don't know how long, so I put X. And from each corner, you can remove a small square with side 9 centimeters. So let's call it the cm. Let's use the cm. From 4 corners, you remove four small squares. This is also 9. This is 9. This is 9. Okay, you remove them. 9 cm. The unit is a cm. And now you follow those 4 segments to fold. You see here, the corner are already removed, so you have a cross. When you have this cross, you fold those 4 fingers up, you will get a box. Fold 4, I call it a finger, up to get an open box. Okay, so that's our idea. You can read the example in the PDF file. The idea is like this. The box has a volume of 144 cubic centimeters. They want to know what this X is. They want to know the dimension of the original square metal. Okay, so that's the example. Let me put it here. Example on page what? Page 99. Okay, let's try to understand this. We are talking about the volume. Let's see what the volume is. First of all, the volume, if you have, for example, if you have something like this, the volume of it is the area of the base times the height. The area of the base times, this is area of the base, and then times height. That's called the volume of this solid. What is a base? This is base. Original shape is a rectangle. Is a square. You remove 4 identical small squares from 4 corners. So the base, the base of this box is still a square. And the total side is X. This side you remove 9, this side you remove 9. So the side of the base is X minus 2 9. X minus 2 times 9 is X minus 2 times 9 is X minus 18. This is a side. When you have the side, the area of the base is X minus 18 squared. X minus 18 squared. Okay, so this is the base. Then what is the height? Check here. For example, this is at a 9 centimeter side, this side. This side, when you fold this finger upward, this 9 centimeter becomes the height. You have area of the base, you have the height, then height times area of the base is equal to the volume. The volume is provided in the problem, 144. So we are going to solve it. We first divide the equation by 9. So okay, 16. 144 divided by 9 is 16. And then we take square root. You get a positive 4 or you get a negative 4. You get a positive 4, you get a negative 4. Square root of 16 is 4, positive or negative. And then you move this 18 to the right side, you get x is 18 plus 4, 22. Or 18 minus 4 is 14. Two solutions. Quadratic equation usually has two solutions. Then the thing is, which one is a solution? This is a concrete problem. It's not the theoretical computation. For the theoretical computation, they are both. But for this concrete problem, remember this is the side of the large square. Of course, it should be greater than 9 plus 9. It should be greater than 18. So this one is too small. You see, if x is 14, you can never cut two squares with a side 9 from the corner. So this is not. So the side is 22 centimeters. Okay. Okay. So this is a section 1.2, the quadratic equations. The quadratic equations, if from the beginning you try to use factorization, sometimes you need some test. You try this, try that, you try several times, possibly you will answer it. If you don't want to do that, you can do the completing square method, or you can do this quadratic formula method. In the quadratic formula, be careful about discriminant. There's three situations. There are three situations about the discriminant. No solution, repeated solution, or two different solutions. Do the exercise. Ask me question if you have. We will continue for the next video. Okay, thank you.